Hello, everyone. Today, we are going to do a packet tracer of CCNA3 version 7, 2.3.11 packet tracer. Determine the DR and the BDR. Here's the addressing table, objectives, scenario. Let's go straight to part 1. Examine DR and BDR changing roles, and you can read all this background information yourselves. Step 1, wait until the amber link lights turn green. When you first open the file in Packet Tracer, you may notice that the link lights for the switch are amber. These link lights will stay amber for 50 seconds. And also you can click fast forward time to bypass this process. Step 2, verify the current OSPF neighbor state. Use the appropriate command on each router to examine the current DR and BDR. If a router shows full drowser, it means that the router is not a DR or a BDR. Let's go to RA. Show IP OSPF neighbor. Let's open all the routers state information. Show IP OSPF for neighbor. RC. Show IP OSPF for neighbor. Okay, now we open all the router neighbors information now. And what question are there? Which router is DR? Which router is BDR? What is the OSPF state of router RA? Okay, from here, we can tell DR, BDR, okay. So here we can tell DR is RC. The neighbor ID is router ID. This is 192.168.31.11. This is router A's router ID. This is router B's router ID. This is router C's router ID. So DR is RC. That's because RC has the highest priority number, which is 2. And RA and RB has the same priority number, which is 1 default number. Here's the 2 to 2. Router B priority is 1. And router A priority is 1 as well. So RA and RB has the same priority number. So when these two routers have the same priority, we need to use another tie-breaking method to elect a BDR. Another tie-breaking method is to use the highest router ID to elect BDR. And we can see from here, RB has a higher router ID. Here's 22. Then RA router ID, AA. So RB is BDR. And RA is drowser. Here's 11 is drowser. Drowser means, well, here drowser is not a DR or not a BDR. So answer this question. DR is RC, BDR is RB, RA is drowser. So step 3, turn on IPOF OSPF adjacency debugging. You can monitor the DR and the BDR election process with a debug command. On RA and RB, enter the following command. This command Okay, let's go to RA. Debug IP OSPF ADJ. ADJ means adjacency. We can see from here. After OSPF space question mark. So it will show you all the options. So we choose adjacency, ADJ. So debugging is on. We do the same thing on RB. Debug IP OSPF. ADJ. Okay, it's on. So we finished 3. Step 4, disable the gigabit Ethernet 00 interface on RC. So use shutdown command to disable the link between RC and the switch to cause rows to change. Okay, let's do it. RC config T configure terminal. So and interface G00 shut down. Okay, now we shut down RC. So become red. So that means RC is DR. So DR now fails. So DR fails. Let's see, wait about 30 seconds for the dead timer to expire on RA and RB according to the debug output, which router was elected DR and which router was elected BDR. So when RD fails, the new election starts. There will be a new DR and the BDR are elected. So let's see which one is new DR. Okay, here DR, new DR is RB. So RB is promoted from previous BDR to DR right now. And the new BDR is RA. So we answered this question. So step 5, restore the gigabit Ethernet 00 interface on RC. Let's re-enable again. No shutdown. Okay. No shutdown. So start to be. So re-enable the link between RC and the switch. Wait for the new DR-BR election to occur. Did DR and BDR roles change? Does it change? Okay, let's see. Show IP OSPF for neighbor. We're still in the process of election. Okay, let's check. All right, so RC, come back now. The DR still RB, the BDR still RA. So that means no change. Explain why. That is because the DR, BDR elections are not preemptive. That means when a new router is added in a network after the DR-BR election, even though this newly added router has a higher priority or higher router ID, it does not take over the DR-BR role. This is because those roles have been assigned already. And the new router doesn't initiate a new election process. That's why the rows doesn't change. Verify. Yeah, we verified already. So if the show IP OSPF neighbor command does not return RB as the DR and RA as the BDR, turn off debugging on RA and RB with on debugging all command and retry step 4 and 5. So this doesn't happen. We can ignore it. Ignore it. And step 6, disable the gigabit Ethernet 00 interface on RB. Okay, RB. So this time it's disable RB. Let's go to RB, gig terminal interface 00. Shut down. All right. This time we shut down RB, become red, and wait about 30 seconds for the hold on timer to expire on RA and RC. So RB right now is DR. So now after we shut down RB, that means DR will fail. The new election will occur. We wait. Let's check the debug. Okay, still in process. Okay, now come out. The new DR this time is R1. So R1 is promoted to DR from previous BDR. The new BDR this time is RC. So we answer this question. DR, BDR. DR is RA, BDR is RC. So step 7, restore RB. Let's go restore. So no shutdown. Okay, RB is restoring and wait the new election to occur. Did the DR and the BDR role change? Okay, let's check if it's changed. The OSPF neighbor still in the process. Okay. Okay, come out now. So this. So now the new election occurred. The new DR this time is still RA, BDR is RC. So no change with the same reason. That is because of the DR and BDR elections are not preemptive. Yeah, that means the new router does not initiate a new election process. That's why. Okay, step 8 is turn off debugging. On RA and RB, let's go to RA. On debug all. Turn off. Okay. Debug all. It's off. Okay. Part 2. Modify OSPF priority at force elections. Step 1, configure OSPF priorities on each router. To change the DR and BDR, use the IP OSPF priority command to configure the gigabit Ethernet 00 ports of each router with the following OSPF interface priorities: R1, is 200, RB is 100, RC is 1, the default priority. Let's start from RA. Configure terminal interface 300 IP OSPF priority. This RA is 200. RB configure interface 300 OSPF priority 100 RB. Okay, RC 50 interface G00 IP OSPF priority 1. RC is 1. Okay, now we changed the priority of each router. Step 4, force an election by resetting the OSPF process on the router. So even though we change the priority of each router, but the election still not happen until we reset the OSPF process on each router to enforce an election to occur. So this command is to reset the OSPF process. Let's go to RA. Clear IP OSPF process. Yes. RB. Clear IP OSPF process. Yes. RC. Clear IP OSPF process. Yes. So now we reset the OSPF process. So we forced an election to occur with long enough of OSPF to converge and for the DR/BR election to occur. This should take a few minutes. All right, according to output from the show IP OSPF for neighbor command on the routers, which router is now DR and BDR. Okay, let's check. Show IP OSPF for neighbor. Okay, this time the new DR BDR come out. The new DR is R1 or RA, and priority is 200. Yeah, because the highest priority. The second one, BDR, with the second highest priority, RB. Okay, so BDR is RB, RA is DR. Good, perfect. So, okay, now if the router do not elect the correct DR and BDR after setting the OSPF for priorities, try restarting packet tracer. Okay, this does not happen, so we can ignore it. So we are done. We are done for this packet tracer of determining the DR and the BDR. Thank you for watching my video. If you like my video and think it's helpful for you, please thumbs up and share with your friend and subscribe. as support to me. See you next time.